top. Well, that will let you know. Okay, good. I'm recording. Okay, so welcome and good morning on this September the 15th of 2020. And this is your digital chemistry class by me, Mr. Deitch. First off, like I will do with all of these sessions, the first part of this session is designed for question and answer. So what I want you to do, if you have a question, please raise your hand. I will call on you. You can then ask your question. If for some reason the hand's not working or you don't have a mic, you can also type it into the chat. Please raise your hand just so that I make sure everybody has a chance. So right now, if you have a question, please click the little icon for the hand raise and I shall call on you and I will do my best to answer said questions. We shall be doing question and answer for the first little bit of these meetings, and then afterwards I have a lesson that I intend to show you. So that's how this is going to go. So if you have a question, please raise your hand at this time. I continue to admit people into the lobby. I don't know how some of you are getting through and some of you aren't. All of you should be getting through. I don't know. As I say, it's above my pay grade. It really isn't above my pay grade, but it's a different pay. You can't read that. That's fine. Of course you can. So, all right. I am not seeing any hands being raised, so I'm going to assume then that surprisingly you don't have any questions, which is a bit of a surprise for me. But hey, what do I know? Maybe everything is hunky-dory and that there's no problem whatsoever. If so, lovely. If not, please raise up and be known. If not, you can always email me. That'll work as well. But otherwise, I'm going to go into a lesson. So if you have a question on the worksheet, a question on the class, a question on anything that we're taking care of, just let me know. Wish I could click a button and have like a tumbleweed, like roll down. That's okay. I hope you're all having a good morning today. All right. Since you have no questions for me, then what I want to do is I want to guide you to something that we're going to be working on both currently and later in the week. And that is significant digits and density, respectively. The two biggest topics of this week are those two. Now, density is your task for today. And I'm just going to briefly go over a couple things with that. And then I'm going to move on to other stuff, specifically significant digits, because that's a bit more of a doozy for most people. Density is relatively easy when you get down to it. The math isn't terribly hard, and the idea is fairly on screen any moment. And I think we're in the transition time. At least I hope so, because everything's slowing down. All right. Of course, this isn't working. Lovely. I love it when there are tech issues. And I don't. It's actually quite the opposite. I don't love it when there's tech issues, but that does happen. Oh, cool. It does look like an awful lot of you are here today. I do like that. I am just turned off, and in which case, I'm sorry. It has been all thing is this is a new webcam, so I don't know why it is not working, but that just does seem to be how it is. Okay. Now let's forget this. Let's do a different thing. There you go. Let's do this. Sure. Okay. No. All right, so we're going to briefly talk about density today. This is the older version of my PowerPoint, but it has a couple animations that I want to make sure work, so I'm going to be showing you this instead. The Google Slides I did update. I did that yesterday, so you should be able to follow along that. I'm going to do this relatively quickly. Like I said, I am recording this so that if for some reason I go too fast and you miss like everything, you can feel free to watch the recording. I'm really trying to make sure that you get the the best thing possible. So here we go. First off, density is all about particles and how tightly packed they are. A high density thing like a solid, especially something like lead, which is super high dense, all those particles are really tightly packed together, and as such, a lot of mass in relatively small space. Lower density spreads around. As we heat stuff up, the density increases. This is a physical property, meaning that it is affected by phase, and that is something that we can measure without messing with the atoms. Is the ratio of mass to volume. Again, it's stuff to space, how much stuff is in how much space. And what's neat is we can identify substances using density, which is going to be the lab that you are going to be tackling later today once I post it. You can see here there's a bunch of different substances there that have just appeared. Water has a density of 1.00 gram per milliliter, which is unique. There's very little things that have exactly one, but water does. Solid water has less of a density, which is why solid water floats, because density is all about whether something floats or sinks. And air, of course, has a really pathetic density because gas particles are very, very spread out. And you can see the density of some other solids. This is also why wood floats on water. Its density is less than water. So if something sinks or floats, it's all about density, every single thing about that. The units are grams per milliliter, which is the exact same thing as grams per centimeter cubed, because a centimeter cubed is a milliliter by definition. As such, they are the same. You will see them used interchangeably, and that trips some people up, so I wanted to show you. The formula for density is D equals M over V. I like to think of it as the DMV of chemistry. It's kind of corny, but I like it. It depends on the substance, not how much. So what it is versus how much of it is. If you have a tiny little cube of lead, it is the same density as a massive block of lead. The ratio of mass to volume will be the same. Greater than one should sink, and less than one will float, because again, density is all based on that. Density is a derived unit. Derived units are units that are based off of other units. We will be dealing with density. We will be dealing with molarity. We will be dealing with specific heat. There's a bunch of derived units that we're going to be dealing with in this class, which is a unit based off of other units. Okay. I don't know if this is going to play. It probably won't because it's being a pain in my butt, but that's okay. This is fun. You can see this. It was a really neat video about a anvil being put into mercury, and a huge 113-pound anvil, I think is what it was, and it will float just like a bit of wood because mercury has such an incredibly high density. If you could stop yourself from sinking through the mercury, you could actually walk on mercury because mercury's density is so high, but because it is a liquid, when you put your weight down on it, it will spread aside and you will start to sink, and you won't be able to get up because it's also super heavy. So thankfully, you're not likely to encounter that at any time. All right, make sure you remember this as a physical property. The phase is important. As we heat it up, the phase changes from solid to liquid to gas, and more space in between means lower density. These particle diagrams are a neat way to kind of visualize how atoms are laid out. As you can see, the three things are A, B, and C, and assume that each dot is 1 gram. So it's telling you how much it is stuff-wise. And as you click through this, it sits there and says, compare them to mass, compare them to volume, compare them to density. Well, mass, you just got to count. And if you count all of these dots here, 5, 9, 14, 18, 23, 27 in A, is more than the, we've got 13 in B, and I believe it's 23 in C. So A has more dots, thus A has more mass, and that makes sense. It's just got more mass. It also has more volume. But when it talks about density, that's different because both A and B have the same density. They have the same number of blocks and the same general space. So A and B would have the same density, while C, which is more tightly packed, would have the greater density. So that's just kind of going through that. Okay, will it float in a bucket of water? This is another little problem. You can go see that later, and that's already on there. Now, this density animation is fantastic, but it may not work on your device because it uses Flash. Flash is an outdated program, and they haven't updated it. They had a link that allowed you to put it in an isolated little box, but I haven't been able to find that link. So if you can play it, cool. If not, I might post a new link in Schoology that'll make it better. But quite frankly, it's a neat little game that talks about how density is. The formula of density, like I said, is D equals M over V. And we can manipulate this several different ways to get different versions of it. I can take it so that I have my V times D, D equals M over V. I take my V's out by multiplying it by both sides, and then bam, I have what I have if I want to get mass. All right, now is this working? I want to see if this works real quick. So, and let's see. No, it doesn't look like it's gonna like me here. Why are you not working? You should be working, but you're not working. Oh well. I guess the programs just don't like each other. Okay, I downloaded something that would allow me to draw on this, but I will just have to use PowerPoint's own thing here. Let's see, pen. Okay, there's more than one way to skin a cat, as the thing says. Let's see if this is going to work. Is this going to work if I do it over here? If I do it over there? No, it doesn't like it. There we go. Thank you for working. Okay, so anyway, that was not what I wanted to do. Okay, so let's say you've got that whole D equals M over V. We can manipulate this formula to get M alone. And by doing that, what we really need to do is we need to times both sides by V. That will get it off of the bottom here, but that means it has to go to the other side. So that means we're left with M equals D times V. So that is what it is to manipulate an equation. If you had that in math, cool beans. If you didn't have that in math, there you go. Manipulating a three-part equation is something that hopefully you can do. And if you can't do it, that's okay. Now, if I want to, well, it's not okay. It means you need help and you should talk to me. So that's something that you are expected to be able to do before you took chemistry. That was part of the prereqs to algebra. So I'm sorry, in this case, that's actually not cool. You're going to need to talk to me. You're going to need to get help, etc. And I will. I don't mind helping you. I mean, that's the point of all this, is I'm here to help you. So over here, if I want to get V alone, because here I got M alone. I did that earlier. See, I've got M alone, and of course, you know, D alone is just, you know, the D equals M over V. I do have a tablet that I would love to hook up to this, but it was also not working today. So, you know, tech issues abound. All right, so here we go. Now, if I want to get V alone, there's a bit of a problem because V is on the bottom. And that's a problem. Whenever something's on the bottom, you don't want it there. You want to get rid of it right away. So we're going to solve this the same way that we solved the last one, is we're going to get V off of the bottom by timesing it to both sides. Remember, what you do to one part of the equation, you have to do to the other. That cancels V on that side and now gives us with what we had before, which is V times D equals M. But we don't want M, we want V alone. So what we have to do then is we have to divide both sides by D. Dividing both sides by D removes the D from before the arrow and puts it after the arrow, which is what we want, which gives us our final manipulated equation of V equals M over D. So if I wanted to find volume using density, there we go. That is a way to do it. Now, next week, I'm going to show you another trick where we can use density as part of a bigger problem, but that's next week, where we talk about unit conversion. This week, we're not going to be converting units per se. We're just going to be using them. All right, so there we go there. Now, so, and that's basically just there. And then it goes over practice. You sit there, you put the one over the other. You have to round. because it started with 3 digits. We'll talk about that later. So there you go. You can see everything that is there. Again, this is available to you, and there's more problems that you can take a look. You're going to ignore the advanced practice, but here we go for the lab. For the density lab, and this lab, you are going to get a bunch of pictures and data, and you are going to be using these pictures and data to try to figure out what the substances are. I think I'm going to give you 4 different substances, and you and your partner are going to figure out what they are. Now, we find mass using balances or scales, and again, you're going to be just given the data. But when we find volume, we need to use the graduated cylinder. The odd shape of the solid does not matter if we use a method called water displacement. What this is we stick it into water, the water fills in the gaps, and we check the beginning and the end. We can subtract them, and then we're going to find out what the volume of the substance was. So the volume of the solid that we put in there. And I got this neat little picture thing that if I put the rubber stopper in, let's see if I'm going to get that laser print. If I've got my rubber stopper here and I put the rubber stopper into the cylinder, as you can see, the volume increases. So you will notice then that all we have to do is subtract. We take the 30 minus the 10 and bam, you get 20. So this is the idea behind water displacement. This is the sort of data table that you are going to be either given or be required to fill in or make. We'll see what it is. I'm pretty certain at this point, I'm just going to give you a bunch of this data and let you figure it out. Now, this is the completed version of it. I didn't have, I may actually do a video where I show you how this stuff is built, but that'll be something that I do later. The mass is something you get off of the scale. Let me change that laser pointer. I like that. The mass is something that you get on the scale. Then what it is you've got your water. And when you put your water into the large cylinder or whatever, you then add the mass to the water. Not the numbers, like you take the mass and physically place it into the water. When you get that, you get a new volume. Then you subtract to get the volume of the solid. Then you have the density of the solid, and you have to be careful with this because in order to get the density of the solid, what you need to do is you need to take the mass of the solid, and the volume of the solid, not the volume of the water. The water doesn't matter. We just use that as a measuring tool. So you need to take the mass, which in this case is 27.39 grams. And you're going to divide that, let's fix that G a little, by the 23 milliliters that you had from the volume measurement. And when you get that, you will wind up with your whole 1.2 grams per milliliters that's listed over here. So that's how you do that. You're taking the mass of the solid divided by the volume of the solid to get the density of the solid. Water only gets you the volume. So the water is just a tool. Like many times, water is not going to really affect what goes on. So but it's an excellent tool. Now, one of the things that you should know is if you use a very small amount of material, you are having a greater chance of getting errors. A smaller amount of the material means for a higher chance of errors. So you have to be careful about that because any little mistake gets magnified. Liquids are much easier. You place the cylinder on the balance, you zero the balance, so you make it so it ignores the cylinder, and then you add liquid slowly. And as you do, you can read the mass from the balance and the volume from the cylinder at the same time. Hopefully I will record or find a video to show you that, but it's pretty easy. Okay, and again, it's fairly simple. You need to know that. So that's just a gist of the lab activity that you are going to be taking care of. That's the idea, the methodology behind it. The people who are here in class are actually going to be doing it. I may even take some video of them doing it and share that with you just to show you how it is done in lab. But you don't have that opportunity. I looked for a good digital version of this lab and I could not find one, which is very irritating because I thought that this of all labs would be something very easily found, but it isn't. So that's just how it goes. Does anyone have any questions now about density in particular? I'll take questions again at the end, but do you have any questions about density? I want to be able to get every misconception right when it comes up. That way that there's not much of a problem. I'll just give you a minute to raise your hands if you so wish. I will call on you and you can share. And I understand that digital learning is really tough. It is, and it can really feel like you're alone, but you're not. You've got a lot of other people in the same boat with you, and quite frankly, they can help. I don't know why anybody's leaving. We still got like more time, but yeah, this is not the time to walk out, but hey, that's how it is. But it can often feel like you're alone, but you're not. I'm here to help you. I can always set up a one-on-one team session with you based on various times. You just need to let me know. But I'm not seeing any questions. I thought by stalling like that, I would give time for questions to be asked. Didn't have any, so I'm going to be moving on. The next topic is significant digits. Now, as far as significant digits is concerned, well, that's a rougher one. That's a topic that's a little trickier than some of the ones we've done before. I mean, measuring has just a couple quirks to it, which I think I did a good job showing on the slides for you. Metric is not hard at all. It's a bit of memorization, a bit of note-taking, not terribly bad, but significant digits tends to be one of the first major stumbling blocks in chemistry. And unfortunately, if you take physics, you're going to see it again. And if you are an engineer, if you're an auto mechanic, you need to at least have a passing knowledge of how this works. It basically is what numbers can you trust and why. I will be posting a couple more videos on that, but just going over some stuff with you now will be what I do. However, I'm going to stop the recording for just a second.